Have you ever wondered how the Pythagorean theorem is used in real life? Well, let's start by unraveling this mathematical marvel. The Pythagorean theorem, named after the ancient Greek mathematician Pythagoras, is a fundamental principle in geometry. It's like having a backstage pass to understanding right-angled triangles. Picture a right-angled triangle in your mind. It has a side you call the hypotenuse, the longest side, and two other sides. The theorem tells us that if you square the hypotenuse, the result is the same as if you squared the other two sides and added those results together. In other words, the square of the hypotenuse equals the sum of the squares of the other two sides. This theorem is like a secret code, unlocking countless real-world problems and scenarios. So ready to dive into the world of right-angled triangles and distances? Now that we know what the Pythagorean theorem is, let's explore its real-life applications. You might be surprised to learn that the Pythagorean theorem has many practical uses in everyday life. For instance, imagine you're standing in a park and you want to walk to the opposite corner. You could walk along the edges of the park, but that would be the longer route. Instead, you could take the shortest path, which is a straight line across the park. This is where the Pythagorean theorem comes into play. It helps you calculate that shortest distance. The theorem also comes in handy when you're dealing with rectangles, specifically when you need to calculate their diagonals. For example, if you have a flat-screen TV and you know its height and width, you can use the Pythagorean theorem to find out the screen's diagonal measurement. This diagonal measurement is typically what's advertised as the size of the TV. Another interesting application of the theorem is in estimating the height of tall objects, like trees or buildings. Here's how it works. You first measure a certain distance from the base of the object, say a tree. Then you measure the angle from that point to the top of the tree using a tool called a clinometer. With these two measurements and a bit of trigonometry, you can calculate the height of the tree. In the world of sports, the Pythagorean theorem is also pretty useful, especially in games like baseball, where players often run from one base to another in a diagonal line. By using the theorem, one can calculate the shortest running path and potentially save precious time during the game. Even in the realm of digital graphics and gaming, this theorem plays a critical role. It helps in calculating the shortest path for characters to move or bullets to travel, contributing to a smoother and more realistic gaming experience. So the next time you come across a problem involving distances, diagonals, heights, or paths, remember the Pythagorean theorem. It's more than just a mathematical concept. It's a practical tool that can simplify your calculations and make your life a tad easier. As you can see, the Pythagorean theorem is not just a mathematical concept. It's a tool we use in our daily lives. But the Pythagorean theorem isn't limited to these simple applications. It also plays a crucial role in more complex fields. Let's dive into some of its advanced applications. In the realm of physics, the Pythagorean theorem is often used to calculate forces. Imagine a box on a ramp. The force exerted on the box isn't just straight down due to gravity, it's also along the incline of the ramp. By using the Pythagorean theorem, physicists can separate this force into two components, one that acts parallel to the ramp and another that acts perpendicular to it. This clearer understanding of forces helps in designing efficient machines, roller coasters, and even in predicting the motion of celestial bodies. Moving on to computer science, the Pythagorean theorem finds its use in determining pixel distances. Whether it's the pathfinding of characters in video games or the precision of shapes in digital art, the theorem provides an accurate measure of distances on the screen. It's a cornerstone in graphics programming, where it assists in rendering 3D models and animations by calculating the distances between different points in a virtual space. Now, let's navigate to its importance in, navigation itself. Mariners and aviators have been using the Pythagorean theorem for centuries to chart their course. By creating a right-angled triangle between their current location, their destination, and a point directly below or above their destination, they can calculate the shortest distance to travel. This method, often referred to as dead reckoning, is a lifesaver when GPS systems fail. In architecture and engineering, the Pythagorean theorem is a silent hero. It helps in ensuring buildings are level, bridges are safe, and tunnels are straight. For instance, when constructing a building, architects use this theorem to make sure the foundation is square. By measuring the diagonals of the foundation rectangle, They can verify if all angles are right angles, ensuring structural integrity. Even in the field of music, the Pythagorean theorem strikes a chord. It's used in the design of musical instruments to calculate the length of strings or pipes needed to produce a particular note. This is because the frequency of a note is related to the length of the vibrating object, and the Pythagorean theorem can help fine-tune these lengths. In fact, the theorem is so ubiquitous that it even finds its way into the realm of biology. It helps in calculating the shortest nerve pathways in the body or the optimal shape of tree branches for maximum sunlight exposure. Essentially, wherever there's a need to determine the shortest or most efficient path, the Pythagorean theorem is likely at play. So whether you're a scientist, an engineer, or a computer programmer, the Pythagorean theorem is a fundamental tool in your toolkit. And even if you're none of these, understanding the theorem can enrich your understanding of the world around you. It's a testament to how a simple mathematical principle can have complex and far-reaching implications. Now that we've seen how the Pythagorean theorem is applied, it's time to see it in action. First, let's start with a simple right-angled triangle problem. Picture a triangle with sides of lengths 3 and 4 units. We'll call these sides A and B. The theorem tells us that the square of the length of the longest side, or the hypotenuse, is equal to the sum of the squares of the other two sides. So we can calculate the length of the hypotenuse, which we'll call C, by taking the square root of the sum of the squares of A and B. That's 3 squared plus 4 squared, which is 9 plus 16. The sum of these is 25. The square root of 25 is 5, so the length of the hypotenuse is 5 units. Now let's move on to a more complex problem involving a real-life application. Let's imagine you're out hiking and you're standing at the base of a hill. You want to find out how high the hill is, but you don't have any measuring equipment. However, you do have a friend, a long piece of string, and the knowledge of the Pythagorean theorem. You ask your friend to walk directly up the hill while you hold one end of the string at the base of the hill. Your friend walks up the hill until the string is fully extended. You've marked the string at 10 meters, so you know the length of the hypotenuse. Ci is 10 meters. You also know that the distance from the base of the hill to the point directly below where your friend is standing, A, is 6 meters. You can use the Pythagorean theorem to find the height of the hill, B. The theorem tells us that c squared equals a squared plus b squared. So we can rearrange the equation to solve for b. B squared equals c squared minus a squared. That means b equals the square root of c squared minus a squared. Substituting in our known values, we get b equals square root of 10 squared minus 6 squared, which simplifies to the square root of 100 minus 36. That's the square root of 64, which is 8, so the hill is 8 meters high. With the Pythagorean theorem, you can solve real-world problems like this one, even when you're out in the wilderness without any traditional measuring tools. All you need is a piece of string, a bit of knowledge, and some creativity. And that's how you use the Pythagorean theorem to solve problems. Let's quickly recap what we've learned today. We started with the basic principle of the Pythagorean theorem, a fundamental concept in geometry that states, in a right-angled triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the other two sides. We moved on to explore its simple applications, like measuring distances or determining the length of a missing side in a triangle. Then we ventured into more complex applications, such as in engineering, architecture, and even in digital media. In our demonstrations, we saw firsthand how this theorem is used to solve problems. We tackled a few examples together, giving you an insight into how this theorem is not just theoretical but also practical. Remember, the Pythagorean theorem is more than just a math concept. It's a practical tool that you'll use in many areas of life, so keep practicing and making the most of it.